cat, everyone. Yes, capiche? This is a cat.
Yes, Steph, it's a cat.
Yes, and this is not a cat. Not cat.
That's a dog.
Yeah, you understand? All right, well, this, my friends, is how we as humans learn about the world around us. And it's kind of how computers have been learning since about 2012, using machine learning neural networks. But it's a whole different ballgame with generative AI, with large language models, or LLMs, gobbling out massive amounts of data to understand the world.
Oh yeah. Unless you've been living under a rock, you've definitely heard of generative AI by now, with ChatGPT, Stable Diffusion, and all those awesome apps developers drop threads about on Twitter.
But here's the thing, as the AI space keeps growing like crazy, most folks still don't quite get what LLMs are and how they do their magic. And in a world where people and kids are getting more and more reliant on AI without fact-checking, taking an LLM's words as gospel, it's vital to wrap our heads around how LLMs learn, improve, and where they might still have some gaps.
Absolutely. And so in this video, we're going to take a deep dive into generative AI, zooming in on LLMs, what they are, how they are made, and what gaps still exist to get them closer to a good representation of the world around us.
Sounds exciting, right? So stay tuned, folks. We got a lot to cover.
Hey, I'm Bertrand, founder of App Economy Insights.
And I'm Stephanie, tech industry veteran, engineer, and creator. All right, let's go on a stroll down memory lane. Back in the 1950s, traditional programming was all about rules. You tell the computer precisely what a cat is, listing its characteristics like the number of legs, ears, and whether it has fur. It's like giving the computer a bunch of if this, then that, instructions that are hard-coded and rigid. And it's great for simple tasks like answering questions, but it's not so great for creative stuff like asking the computer to write a story about a cat.
But as AI and machine learning advanced, we found more dynamic ways to teach computers. Enter neural networks. Here's the deal. You show the computer a bunch of cat pictures and you label them as cat. With enough labeled examples, the computer learns to recognize what a cat is and what it isn't. Remember that app from the Silicon Valley TV show that identified hot dogs and not hot dogs from pictures on the phone? That's the magic of neural networks at work. Maybe not in Jin Yang's case.
And now we've got generative AI, and it's like telling the computer to read a ginormous stack of books. The computer forms its own connections and associations between concepts like cats through this thing called self-supervised learning. It's like the computer teaching itself. And after all that reading, you can ask it what a cat is, and it'll tell you based on probabilities what a cat is. It's essentially giving you a really smart guess.
Isn't that fascinating? AI has come a long way, and generative AI is pushing the boundaries of what computers can do. They are getting better at understanding the world in a more human-like way.
All right, let's dive into LLMs and see what they're all about. In simple terms, LLMs are like prediction engines. They use a massive amount of data from articles, Wikipedia books, and the internet to give human-like responses when we ask them questions in natural language.
Now, in more technical terms, LLMs are machine learning models trained through data input-output sets. The text they learn from is often not labeled or organized, as they use self-supervised or semi-supervised learning methods. Information is fed into the LLM, and its output is what it predicts the next word will be. That's cool, right? The input data can be proprietary, or, like with ChatGPT, anything it finds on the internet.
Oh, and have you heard about parameters? They're like the LLM's little buddies that can help it make decisions. Picture them as millions, billions, or even trillions of little helpers in the model. OpenAI's GPT-3 LLM has an impressive 175 billion parameters, while the newer GPT-4 boasts a whopping 1 trillion of them.
Here's a fun example. You can type something like, "The quick brown fox jumped over the..." in an LLM prompt window. And guess what? The LLM could give you different answers like log, fence, or lazy dog. There is no one right answer, but each option has a chance based on the data the LLM learned. So if lazy dog happens to be the most probable answer based on what it knows, that's what the LLM will complete the sentence with. But hey, It's all about probabilities here. The LLM assigns a percentage to each possible answer, like maybe lazy dog gets 90% of the time and fence 3% and log just a tiny, 0.005%.
Right, and that makes it great for creative tasks. But if you ask a question like, hey, what's the best way to lose weight in 2 months? You could get very different answers based on the plethora of opinions online. But you also might get something like this. And that leads us to how you train an LLM to answer this way each time.
All right, so before we dive into how to train an LLM, if you like this video and want us to keep this up, hit that subscribe and notification button. By doing so, you'll get instant access to our weekly videos as they are released.
Yep, and every time we get a new sub, we get a little better at making these videos so that AI can't replace us. So don't wait because we're depending on you.
All right, so let's break down how to train an LLM. It's not as straightforward as just feeding it loads of data. You see, LLMs can be a bit unpredictable at first. Since they are trained on approximating the vastness of the internet's text, they can end up being somewhat chaotic and might even include undesirable content. Imagine having access to millions of text or code units. It can be overwhelming and leads to vastly different answers and tones each time you ask it to plan a trip to Lake Tahoe, for example.
So to refine and make it more reliable, we use a process called fine-tuning. It's like giving the LLM some extra training to excel at specific tasks, kind of like becoming an expert in a particular subject. So we take the base model and we train it further using new specialized examples like history or medicine. And each time, each new example helps it understand the specific topic better.
But here's the thing. We want to ensure the LLM behaves according to human preferences and avoids offensive or biased content. For instance, when we ask it to plan a trip to Lake Tahoe, it should respond positively, present it in a list format, and remind you that the answer is just an example, and you can customize it to your liking.
So how do we steer the model in the right direction? That's where reinforcement learning and human feedback, or RLHF, comes in. We get human feedback on the model's answers, rate it on helpfulness, truthfulness, and harmlessness, and then we use this data set to train a new AI agent that rewards the base model for good behavior and penalizes it for bad behavior. Essentially, we reinforce certain behaviors to align the model more with human preferences.
Now, that was just a simplified version of LLM and AI implementation. There's much more to it, like sourcing the right training data, data engineering, prompt engineering, and operational stuff like hosting the models, monitoring and retraining them. Of course, with all of this in mind, there are risks to consider. One is bias. Even though the teams creating LLMs actively fight against bias as LLMs undergo evaluation and tuning, they might end up reinforcing certain behaviors that introduce other biases. The model behaves according to what humans have chosen, which could lead to a reduction in diversity of output, hindering the exploration of new ideas. If the task is to assist in novel ideas, a reduction in diversity of outputs could hinder finding new intriguing concepts. So the process of RLHF should be treated with care. And if you use LLMs, don't just blindly accept what you see. Think about the answers provided.
Yeah. And something else to keep in mind is it's actually often hard to trace back how an LLM got to its answer. In fact, some researchers have seen emergent behavior with models, like a model trained on one programming language generating code in another that it wasn't trained on. And this is also why hallucinations are key to keep in mind. LLMs can generate information that seems plausible, but is entirely made up by the model itself. They learn from vast amounts of data, right? But this can also lead to contradictions or false information, like recommending books that don't actually exist or stating that 220 is less than 200.
To tackle hallucinations, researchers and developers are working on refining the training process using techniques to minimize the generation of false information, like fact-checking. This is where LLMs need to retrieve information from external sources and provide citations to verify the accuracy of the content. Efforts like OpenAI's WebGPT and DeepMind Sparrow are already underway to improve LLMs' reliability.
Absolutely. So while LLMs have amazing potential, we as consumers should be conscious consumers. Does the burden of proof land on the user or the creator of these LLMs? I think both. The path to reducing bias and minimizing hallucination lies in continuous improvement through responsible development and your user feedback.
You're spot on. LLMs and generative AI are here to stay, and they are transforming the way we interact with technology. But as we move beyond the initial hype and excitement, it's crucial for not only developers, but also users of LLMs to grasp how they are built so we understand the power and implications of these tools.
Yes, 100%. And we want to strike a balance between embracing the potential of LLMs while staying vigilant. It's essential to be informed users and understand how these models work to make the most of their capabilities.
And just to clarify, while we did use ChatGPT to assist with some part of this video, the overall narrative and unique tone are still crafted by us. And we chose the cat and dog photos, by the way.
That we did. So now that you've gained an understanding of LLMs and their construction, the next step is to explore the broader landscape of the generative AI technology. Learn about the major players and where the industry is heading.
You can check out our AI Wars series for a comprehensive course on generative AI tech. It's a fascinating journey, and by staying informed, we can all shape the future of AI responsibly. So we'll see you right there now.